Today's lecture 5 of Basic Electronics is based on Diode Approximation Part 2. So let's begin with our today's lecture. So today we will be doing about the next part of the diode approximation, that is the three types of diode approximation. When there is a switch, then it is the first approximation. Whenever there is a switch with a battery, then it's a second approximation. When there will be a switch with a battery and an internal resistance, then it will be the third type of approximation of the diode. Okay, now we will be beginning with the first approximation. The first approximation of a diode is simply a switch. It is nothing, it's just a switch. Okay. If the diode is forward biased, then the switch is closed. That is, if this switch is forward biased, then the switch will be closed. That is, the diode will behave as a conductor. We know that when it will be a perfect conductor, when it is forward biased, right? So it will have zero resistance, right? And it will also have zero voltage drop. Yes. If the diode is reverse biased, that is, the switch will be open. That is, it will be open. Okay. And we know that whenever it is reverse biased, it will behave as an insulator and with infinite resistance. Right. Now we will proceed with the second approximation. Now let's see our second approximation. The second approximation requires 0.7 volts of forward bias to overcome the barrier potential. I told whenever you will see a switch with a battery that will have a 0.7 voltage, and why it should have just overcome the barrier potential. Whenever it will be open switch, it will be reverse bias. And we know that reverse bias means there will be no current will flow. That is, it will have resistance which is infinity, but current will be always zero. Now we will see when this battery will be forward biased, it will be closed. So whenever in the forward bias it will be closed, then 0.7 volts appear across the diode and current will flow. We know that whenever it is forward bias, it acts as a conductor. That means it will help us to flow the current, and so whenever it will be forward bias, it will have 0.7 volts appear across the diode, which will help for the current flow. Before moving forward to the third approximation, we should see the graph of the second approximation. Y-axis has the current, right? X-axis has the voltage. As we know that the second approximation will have a battery with voltage 0.7, so we will have a straight vertical line here, which will denote as 0.7 volt. So this V dash will be equal to 0.7 volt, right? Now we will go to our third approximation. The third approximation includes both the 0.7 volts barrier potential and the internal resistance of the diode, called the bulk resistance. See, whenever it is reverse bias, it will be open switch. Reverse bias means insulator. Insulator means the resistance will be, that is, whenever it will reverse bias, it will be insulator, and whenever it is insulator, that means the resistance will be infinite but the current will be zero. And whenever it is forward bias, it will be closed switch. That is, it will act as a conductor and it will have a resistance 0 and the voltage drop also 0. But the current will be infinite, right? Now we will see the graph of the third approximation. This is the graph of the third approximation. Y-axis will have the current and X-axis will have the voltage, right? Here the voltage will be 0.7 volt, but as it is the internal resistance, that means there will be a little tilt. It will be not be vertical, it will be little tilted as the resistance will oppose. So here the V voltage will be 0.7 volts plus the current and the internal resistance. Okay, why it is so? Because we know that V is equal to IR. So this voltage plus this one. Okay. So this is a third approximation. Now we will see where this different approximation used. The first approximation is basically used in troubleshooting, or we can say in debugging. The second approximation is used when a more accurate determination of load current and voltage is required. Basically, in practical process, we use second approximation. The third approximation is used during the original design of diode circuit. Whenever we will design the diode circuits, we need a third approximation. So we come to the end of the part of diode approximation. Thank you.
It's the quote time. I find hope in the darkest of days and focus in the brightest. I do not judge the universe. I thank all of you understood today's lecture and thank you for watching.
Wow, that's impressive! You have completed a magic today. For more videos, subscribe. Join our Facebook group and Instagram page for group discussion and live magaz videos for exam preparation in an hour. We start a class-like community for students to learn from a friend in a simple way and support them in their own languages. If you are willing to be that one friend who saves us at the exam night preparation, then please join us by visiting classfly.in.